This is section 8.5. We're going to look at practice A. We're just going to do trapezoid problems. So I guess we'll look at number 1. Points J, K, L, and M are vertices of a quadrilateral. Determine whether that shape is a trapezoid. So you can get a piece of graph paper. You can plot these points. I'm going to do my best here. Hopefully everything looks okay. But that's where point J would be. I'm going to go one left, one down. K would be 0, 3. L would be 3, 3. And M would be 4, negative 1. So I'm going to connect those. It sure does look like a trapezoid, but I need to make sure. And the way you're going to do it is by slopes. So look at the slope of line or segment KL. Notice how the y values are the same. That means the slope of that guy is 0. I'm pretty sure the same thing happens with segment JM. If you notice, the y values are negative 1. So segment JM is also going to have a slope of 0. That means those are parallel. That's a good start. To be a trapezoid, you got to have one pair of parallel sides, and we have that. The only problem is the other sides could be parallel too. Now, if you plot this on a piece of graph paper, I think you'll be able to tell when they're not parallel. Let's just make sure we know these aren't parallel. What is the slope of segment KJ? It looks like I'm going up 4 and 1 to the right. Segment LM, I need its slope. It looks like I'm going up 4 and 1 left. Let me make sure I'm counting right here. Definitely going up 4 and 1 left. Okay, so those slopes aren't the same. That means those two segments are not parallel. Okay, so you have one pair of parallel sides there that is a trapezoid. So we're going to say yes to that one. Just find the slope of 4 segments. You need one pair of parallel sides. We'll jump down to number 3. 3, 4, and 5 are all the same. We want to find the measures of the angles. This is definitely a trapezoid. In fact, it's an isosceles trapezoid. That means your base angles are the same. Okay, now there's 2 pairs of base angles. There's an acute pair and there's an obtuse pair. What's left over from 180? That'll be your obtuse pair. I think it'll be 127. So it's always going to work like that. We'll move down here to number 7. Find the length of the mid-segment, and we're calling that segment RT. A mid-segment connects midpoints of the legs of a trapezoid, and you know that's the midpoint because you have these markings. If you didn't have those markings, that wouldn't be guaranteed to be a mid-segment, but they're telling you that it is. How long is that mid-segment? Well, the one thing we know is that mid-segment is parallel to the other bases, the top and the bottom. And remember, it's also half the length. So it's very simple math. Just add your bases, divide by 2. 21 divided by 2 is 10.5. Is 10.5 directly in between 9 and 12? Yeah, it's 1.5 units from both. So that sounds good. Always, sometimes, or never. A trapezoid is a parallelogram. That's never. The bases of a trapezoid are parallel, always. The base angles of an isosceles trapezoid are congruent. That's always, both pairs of them. The legs of a trapezoid are congruent sometimes. If your trapezoid's isosceles, it will be. If it's not, then they won't be. Those next problems are kites. We'll do those in another video. Same idea here. You got mid segments for this next section here. Maybe we'll do 21. Maybe that looks the trickiest. How long is that other base if you know the mid segment's 14.5 and the longer base is 19? Well, if you notice, that longer base is 4.5 units longer than the mid segment. That means this guy has to be 10. For it to be the average, these are going to be 4.5 apart, the mid segment and the long base, and then the mid segment and the short base will be 4.5 apart. So all I'm doing there is subtracting again. That's where that 10 came from. And there's other ways to do it. I think that's the easiest way. Okay, so 3 times what plus 1 gives you 10. I think you know that's got to be 3. 3 times 3 is 9, plus 1 is 10. I guess we'll do 22. So it tells you there that these are trapezoids. Find the length of A and B. I guess they want you to say these are mid segments. I guess. So notice how the difference between this yellow guy and this orange guy is 6. That means this blue guy is going to be 6 less than the orange guy. So that guy will be 18. And then this guy, we'll call him green, he'll be 6 units less. Let's do this proof. All right, so we have some given info. They're telling you these are parallel. So it's making it look like it's a trapezoid. We're not so sure that it's not a parallelogram yet, but definitely a trapezoid so far. We got this yellow triangle, and that's going to be congruent to this triangle. Okay, so using that, let's see if we can show that the whole entire figure is an isosceles trapezoid. Yeah, and I think we can. How can we say that the shape is a trapezoid? Well, it's got one pair of parallel sides. Can we prove that the other sides aren't parallel? Yeah, I don't really like that. I don't think you can, but definition of a trapezoid tells you if you got a pair of parallel sides, I guess it could be a trapezoid. Here's some other given. The yellow triangle and the pink triangle are congruent. Now, I know where we're going. Remember, we're trying to show this as isosceles, so you want those legs to be the same. If the yellow triangle and the pink triangle are congruent, then those 2 legs are congruent too. That's CPCTC. So that's an isosceles trapezoid by definition of isosceles trapezoid.